So what do we know about global warming? And greenhouse gases for that matter? Not nearly enough according to NASA researchers, which brings me here.
I'm at NASA's Jet Propulsion Laboratory, where top scientists are studying greenhouse gases. Now, they're a major part of climate change. Let's get the scoop.
Here at JPL, it's not just about studying the universe. There's still a lot to learn about Earth, the place we call home, especially when it comes to greenhouse gases, climate change, and what the Earth's future could look like.
One of the great questions of today is, even though we know for a long time now we've been letting carbon dioxide out into the atmosphere, emitting it when we burn fossil fuels like gasoline, coal, natural gas even, what we don't really know is how the nature is responding to this.
It's that question NASA scientist Mike Gunson hopes to answer. He's got his eye on the Earth's carbon cycle and is part of the Orbiting Carbon Observatory Team, or OCO.
Our overall objective is to measure the distribution of carbon dioxide around the world in the Earth's atmosphere.
CO2 is a crucial part of the atmosphere. In fact, did you know we actually need it to survive? For instance, plants use sunlight and CO2 for photosynthesis. Ecosystems even emit some CO2 naturally.
Good news, we need greenhouse gases because that maintains life here on the planet. But on the other hand, if you have too much of these greenhouse gases, it could start to warm up beyond where we could say the Earth is even habitable.
Too much human-emitted CO2 in the atmosphere will trap too much of the sun's energy, heating the Earth up. And it's something that's already happening.
Global warming is a very real problem. Climate change, we see the world changing faster today than probably it has in any time in the past 1,000 years.
So what could a warmer planet look like? Just look to the solar system and Venus, the second planet from the sun.
A runaway greenhouse effect is not a pretty sight, and you can see that on Venus.
It's not a pretty place.
It's not a pretty place, and very inhospitable.
While that's an extreme example, you get the idea. We certainly don't want to end up like that. Fortunately, even though mankind hasn't done a great job of keeping CO2 out of the air, nature has. The Earth's oceans and forests act as carbon sinks, storing some CO2, but there are consequences to that as well.
We want to understand the role of forests, oceans, and other areas in effects on carbon dioxide concentrations.
Once launched into space, the OCO2 will provide the first complete picture of human and natural carbon dioxide sources, and those sinks we mentioned. It will map them and study their changes over time. It will also look at reflective sunlight.
As that sunlight passes through the atmosphere, some of the sunlight is absorbed by carbon dioxide and oxygen, and we actually fingerprint that absorption of sunlight so that we can actually measure then the amounts of carbon dioxide present in the atmosphere.
And the carbon dioxide up there stays there for hundreds of years. And while NASA can use data to predict the future, Gunson says it depends on what we do now.
If there were a magic wand, if there were one thing you'd want to do, is you want to stop completely putting carbon dioxide into the atmosphere. But unfortunately, day-to-day life hinges on driving your car, using electricity, whatever you think of. We depend on energy provided by burning fossil fuels.
And as long as that continues, climate change will be a reality. And those of us on planet Earth will be forced to adjust to a different world.
For every person going through high school today, unfortunately what they're going to inherit are a whole new set of problems. They're going to understand how they're going to adapt to a changing climate.
A climate that's changed before and is changing again.